Yeah, phasor diagram. Phasor or phasor diagram. What is meant by phasor? Phasor means a sinusoidal alternating voltage can be represented by a vector which rotates about an origin in anti-clockwise direction, a constant velocity of omega. Such rotating vector is called phasor. So now we are going to show oscillation. That oscillation in an anti-clockwise direction, we are going to change into. We are going to explain the vector in a rotating vector. So that is called phasor, right? So see that here that the blue color line is the voltage, red color line is the flow of current I. So Vt equal to V0 sin omega t is the at any instant of time that is the voltage. V0 shows the amplitude or peak value. That is the maximum amplitude of the wave. Okay. Then omega is the angular frequency. Omega indicates the angular frequency. Omega equal to 2 pi f. That is, you know, the frequency of the oscillation. Okay, so it's called Vt equal to V0 sin omega t. Like that, you can define that x is equal to A sin omega t. That is a wave. So now you can see that already we know that in 11th standard we studied that the same thing. See here that oscillation of the wave is indicated in a circular motion. So see that the red color line is a wave. The particle moving in a circular path. See the straight line. So now we are going to define that particle moving in a circular path with the angular velocity of omega, that is defined in the letter, that magnitude is V0, angular velocity is omega, and V0 sin omega t is indicating in a phase diagram like this. So direction is constant for angular velocity, it is rotating, see that? Like that the particle is moving in a waveform that will indicate in a circular motion. So this is called the phasor diagram. So see how the waves are produced. That is moving up and down. Okay. So method of producing the sine wave. So the length of the line segment equals the peak value of M of the alternating voltage at current. The angular velocity omega is equal to the angular frequency of the alternating voltage. The projection of phasor or any vertical axis given the instantaneous value of the alternating current. The projection of a phasor on any vertical axis gives the instantaneous value of alternating voltage. The angle between the phasor and the axis reference indicates the phase of the alternating voltage. So it is that capital letters are indicating that amplitude and peak value, maximum value of voltage and current. So V is the voltage, I is the current. That's the maximum value, magnitude under the current. At any instant time, the small amount of current is indicating, depending on the time period, the small value is indicated, small v of t, I of t, v comma I, at any sort of time. So in the phasor diagram, wavelength diagram indicates that I and V and what is the phase difference between the current and the voltage. So see that this is the motion of the current, that is indicating the vector in a perpendicular axis. So it's V equal to V of t equal to V equal to 0. That is total voltage of the current. Now it's a 90 degree, in anti-clockwise direction, it's 180 degree. That is negative output, maximum amplitude in the opposite direction. Then again it will see that. So the waves are produced like this. So negative side of maximum, positive side maximum. Then maximum minimum is in the opposite direction. So any circuit it is connected to the AC current. The resistant and voltage, we have the phase difference. The voltage and current is not in the same phase. So any current means we have the potential V and the flow of current I. So we have some phase angle. That is the angle. There is a phase difference between the two waves. So see that this blue color is a voltage and red color is a current. There is a phase difference between that. Phase difference means that angle. So some angle is different. That's timing, it will changes and it will move in a different place. See that. So when you combine that, you can get like this, the two waves. voltage and current. Now you can see that it is producing a sine wave. So V equal to Vm sin omega t for voltage, I equal to Im sin omega t for the current. So now you can see that phase difference is same, means phase difference, there is no phase difference. Omega t minus phi means that current is lags the voltage by the phase angle of pi by 2. So it is the same phase. See that it is phase difference. The two lines, blue color line and red color line. See that two waves. Now it's in a phase difference. So pi equal to 2 pi, t equal to t. That's time period. So the phase difference for the time period of delta t, that's the phase difference of t by 2 pi into pi. So that is the phase difference between the voltage and the current. Maybe it is more than the phase is more than the current or less than the current. That amplitude is because does not it gets the same time that amplitude or the zero or maximum. So see that voltage. Now that current leads the voltage of pi by 2. See that current is moving fast. So the voltage is lags behind the phase angle of phi. Okay. So the current is moving. So omega t plus phi. So here current leads the voltage of by the phase angle of phi. Okay, that's why the phi is there. So now there is no phase difference, it is like this. Suppose phase difference is, it is displayed like this. So at any cycle, that applied voltage and current is like this. There is a phase difference. Current lags behind the phase angle of phi. See that minus phi is there. That means that voltage and current are not in the same phase. That is pi is here. See, it is negative sign. So minus pi. So here current is here, voltage is here. So current is here, the voltage is here. Phase difference is pi, minus pi. So now you can see the waveform. So it's called phasor diagram. We are indicating that vector into a waveform, rotational move. See that. So the two wave has the phase difference. They are not in the same phase. They are producing the phase difference. It may be a positive or negative. So the see that two lines are not at a phase. That's the difference. Delta t or phase phi. Now you can see that current I0 is leads the voltage phase angle of phi. So voltage oda current munnadi irukku red color line. Voltage is blue color line. That current is leads the voltage phase angle of phi. So see that now again. Now the current leads the voltage by the phase angle of phi. See. So the waves are produced like this. So that is a phase difference. Suppose that current and voltage are in the same phase. That means there is no phase difference between the voltage and the current. So it means that two voltage and current are occurring in the same zero and maximum occurrence in the same time period. So see that there is no phase difference between the current and the voltage. So the waves are produced like this. So it has maximum and minimum at the same time. See that. So there is no phase difference between the voltage and the current. Okay, so this is the phase diagram for the zero phase difference. So phase difference may be zero, or current leads the phase angle of pi by 2, or voltage lead the phase angle of pi by 2. These are all the possibilities of producing the waves.